Welcome back to the Foundry by Forge College. I am absolutely thrilled you're tuning in. Today, we're diving into our explainer on shell scripting foundations for Solana CLI workflows. Now, to give you a little context, this is a core piece of our scripting and automation with Solana CLI module, which sits inside the Mastering Solana CLI track, all part of our broader Solana Development Tools course. Wow, that's quite a mouthful, but trust me, it's exactly where you want to be. In our previous lesson together, automating advanced Solana CLI workflows, we had a lot of fun stringing together commands to get things done quickly. But today we are leveling up. We're upgrading from those basic ad hoc scripts into robust, production-ready engineering blueprints.
So I want to kick things off by asking a question that literally strikes universal dread into the heart of every developer. What happens if you run your script twice? Seriously, imagine your finger slips on the enter key or your CI pipeline just stutters. Best case scenario, you get a couple of annoying error messages. Worst case, you've just accidentally created a dozen duplicate token accounts, completely drained your test SOL, and you're currently hiding under your desk. We have all been there, right? To avoid that kind of absolute chaos, we need a complete shift in how we think about automation. The mental model you need to adopt is this. Treat your scripts as controlled, mutating transactions. Basically, you want to think of your shell scripts almost like single-use smart contracts. They absolutely need strict preconditions, heavily guarded actions, and explicit rollbacks. Because otherwise, a script that works perfectly fine on your laptop on a Tuesday morning might completely explode a shared build server on a Friday night. Okay, here's our schematic for today's masterclass. We'll be looking at the scripting blueprint, variables and pipes, the idempotency mindset, 5 steps to automation, and we'll wrap up with safe error handling. Let's jump right into Section 1, the scripting blueprint.
Moving right along to Section 2, variables and pipes. These are our raw materials.
You know, every great blueprint needs solid raw materials. And right off the bat, we have a really critical distinction to make. Local shell variables versus exported environment variables. A local shell variable is strictly for your internal script bookkeeping. Think of it kind of like defining your RPC URL just once at the very top of your file. But an exported environment variable, that's entirely different. Exporting it makes that variable visible to child processes. This is exactly what you use when your Spawn's Solana CLI processes actually need to inherit configuration directly from the environment to work properly. Next up, we have command substitution. This is essentially how we capture the standard output of a command directly into a variable. Now listen, you want to use the modern $ parentheses syntax here. Please, let's leave those old messy backticks in the past where they belong. Instead of querying a public key 5 different times throughout a script, you just capture it once straight from Solana keygen pubkey, store it, and reuse it instantly. It's so much cleaner, it nests reliably, and it drastically speeds up your execution time. But here's the catch. All those variables are completely useless if you ignore the quoting rules. Leaving variables unquoted so they split on spaces will cause absolute havoc in your terminal. It's honestly like dropping a gremlin directly into your file system. Double quotes are your structural beams. They preserve your variable expansions and they save your JSON blobs from being totally misinterpreted. And what if you need raw, untouched strings? Easy. Just wrap them in single quotes. Mastering this one simple thing prevents so many silent, maddening bugs. All right. Section 3, the idempotency mindset. Idempotency is just a fancy engineering term for making sure rerunning your script doesn't blow everything up. It is the ultimate safety net for Web3 automation, and there are 3 core strategies we use here. First is detect and skip. This is perfect for expensive or irreversible actions. You just probe the system state first, and if the resource is already there, you skip it. Simple. Second is declare and compare, which is best for safely updating things. You check your live config against your desired config and only apply the actual differences. Finally, we've got safe create retry for handling race conditions. This is where you attempt to create a resource, but you happily tolerate an already exists error as a total success. Time for Section 4, 5 steps to automation. Okay, let's assemble all these raw concepts into a battle-tested workflow. This is the exact sequence you should follow every single time you build a script. Step 1, parameterize. Declare all your inputs right at the top. Step 2, validate. Always check your preconditions. Step 3, act. Execute your commands using those idempotency strategies we just talked about. Step 4, verify. Immediately check the on-chain state to make sure it actually worked. And finally, Step 5, report. Emit clear, structured logs and proper exit codes. I actually have to pause here for a second because this is so important. In our Forge College developer courses, we constantly see students skip that vital validation step. People just get way too eager to smash that mutate button, and they completely skip the read-only queries. You have to always check your connectivity, ensure your key pairs are readable, and validate your configs before you attempt any destructive command. And part of acting safely means acting conservatively. You need to enforce conservative defaults across all your scripts. Keep your destructive operations locked behind an explicit -apply flag. That stops accidental deployments dead in their tracks. Build out -run modes as a first-class feature so you can test your logic without the stress. And please, for the love of Web3, never ever hardcode your secrets directly into your scripts. Let's hit our final core topic, Section 5, Safe Error Handling. Look, even with the absolute best blueprints, earthquakes happen, networks drop, RPC nodes lag behind, things break. To avoid the absolute nightmare of silent failures, you need to memorize this piece of engineering jargon right now. Set-EUO pipe fail. Put this at the top of virtually every script you write. It immediately aborts on any non-zero command, it throws an error if you use an unset variable, and crucially, it catches pipeline failures. If you pipe some output into JQ and the Solana command actually failed, this stops the shell from reporting a false success. It's a lifesaver.
You can even take this a step further by using error traps, like trap on error $O error. When a failure happens, this little trick captures the exact line number of the crash. By returning distinct exit codes, maybe one code for network drops and a totally different one for missing configs, you allow your CI systems to actually understand what went wrong, rather than just blindly guessing in the dark.
Wrapping things up, Section 6, Next Steps and Recap. We have covered a tremendous amount of ground today. Here are your key takeaways to bring to the construction site. Fail early and loudly using set-EUO pipe fill. Always detect the existing state to ensure your scripts are idempotent. Make those side effects explicit with flags. And finally, a bit of homework for you. Gather up some sample key pairs and local RPC URLs to prep for our very next lesson, which will be on writing reusable scripts.
I want to leave you with this final provocative thought to really test your current automation safety. If your script fails halfway through today, is your Solana environment safe enough to simply run it again? If your answer is no, well, now you know exactly which principles to apply next. Thank you so much for joining me for this explainer. Be sure to visit forge.college to dive deeper into the subject and truly master the Web3 workflows that will set you apart as a developer. Keep building safely, and I'll see you in the next one.